Alright guys, in 910 physics, I just want to give you a rundown of the physics lab, what's expected of you, and kind of give you a rundown of how to do this lab. So first off, you have two essential questions. What's the ratio between the number of pulleys and the force required to lift the mass? And also, second question is, what is the relationship between the force required to lift the mass and the length of the rope? Now, if you guys remember, those two concepts are going to deal with the ideal mechanical advantage and actual mechanical advantage that we talked about with our last section of pulleys. So for this first, when you click this link, you'll be brought to a page that looks like this. It says simulation. In this program, you can change the size of mass, change the number of pulleys, you can change gravity, change the planet you are on to conduct this experiment. Click on the variables to probe and see how much the applied force to lift it. So it says on the image of the pulley indicates the input force and output force. So let's hit begin. So we have the input force and output force. We have our forces right here. So this is going to be our input force we are going to be recording. So it says change on the second question, part 2, it says change the number of pulleys and fill out the table below. So at 6 pulleys, you can change whatever ones you have here. If you want to change the masses, as long as you guys keep it the same throughout the whole experiment, that is fine by us. I just keep it the same how it is right here. So if I look at 6 pulleys and I were to click on this, my input force would be 1.65 newtons. Please make sure you are putting in your units. So this we're going to write for our first one. Are you seeing this chart goes right into that first box of input forces. Then we just change the number of pulleys. So now the next one is going to be 5. So the number of pulleys, 5. Click on it and record. Going through them as you go. 4, 3, 2, and 1. And you're going to record them all in here. Now this next one is you're going to complete the sentence. It says, as you increase the number of pulleys, what do you think is going to happen? So as you increase the number of pulleys, you can say, you can talk about the force change. You can talk about how much the rope changes, how much advantage you think it's going to have, if it has a greater or less mechanical advantage compared to how much force is required. For the second one, oh sorry, this picture should be lower. This is part of the second one. Number 4 for this one says, how could you apply this knowledge to move furniture? That could be something you could use. Think about how, if you have tried removing a couch, how hard is it to pull it with it, and how could you use pulleys to help you with this? Now this image right here is supposed to be the second one. That's our second lab we're going to be doing. Looks just like this. So you have 3 different pulleys you're going to be testing. This is a diagram you're showing a picture of 3 pulleys, each with the same size weight attached. You can use this handle to lift the block in the image, showing how much readings on each system to complete the table. So for the first one, the number of pulleys, we have the 4 pulley system. So we have 1, 2, 3, 4. We have 4 pulleys here. So what we have to do is we're going to see force needed to lift the 10 kilogram blocks by 10 meters. Well, we're going to go and lift it. You see this green bar right here? This green bar, let me zoom in for you. This green bar right here, that's going to be our distance. As we pull it, these are the meters it goes. So you can see when we stop at 10, how many Newton force, or this red bar, do you see moving? So we go up to, I would say, about 6 Newtons. This is how far do you need to pull the handle down? Well, the handle right here is about at the 30 meter mark. We have to move about 35 meters. So here we can say, how long does it read on the pink scale? How much you're reading down? Well, about 6. How far did the green handle pull down? To the 35 meter mark. You do the same thing for the next 2 ones on this one. 2 more to do. So the last one we're going to do is you're going to be reading these questions. So number 6 reads the paragraph at the bottom of the explain that explains the mechanical advantage is the mechanical advantage calculations below. So if you know the load force is 24, we're going to divide by the reading of the scale. So we read of the pink one. We're going to find the mechanical advantage. So for the four pulley system, you would go look at the top here. How much Newton force do you have? Well, you had 6. So you can do 24 divided by 6 to get your answer. You do the same thing for 2 and 3. And that's all you do for the second one. The last one we're going to do is the third pulley system you have here. In this one, I know it's going to start you off at the angular view. I like the side view better. If you, let me zoom in so you guys can see. If you guys like the angle view, go for it. You can either go front view or side view. I personally like the side view because it just lets me see it a little bit better. Okay, so it says leave the settings as they are. You will just be toggling the button of the pulley system to complete. It says run the simulation using a single fixed pulley and then single movable pulley. So we have our single fixed, and we're going to hit play. As we drag it down, what's going to happen? It's taking a lot of force. You can see a 5 Newton applied force is lifting it very slowly. So it takes a very lot of force to move with one fixed pulley. Okay. So the next thing you can do is ask here which one is required to least amount of movement of the force, which one has the largest force. Then for number 8, run it with a single compound. You're going to click on this button now, a single compound. And you can pull down on it on here. You can just hit play and see the force applied and how much it's moving. You can see the Newton forces that changed here and all that fun stuff to answer the questions. Then number 9 says a double compound, and you can go from there. See how much Newton force it takes to lift it. And number 10 is just answering the essential questions that you had from before. Also for number 1, or for the first one here, you can either do either one of these two. I'm sorry, I should correct myself. You can do this one, the single fixed, and then the single moving. See how the force has changed. So if you guys have any other questions, please feel free to contact me. I'll be on this document. I'll also be hosting a Google Hangout around 1 o'clock today of Friday the 20th. So if you have any questions, please feel free to ask me. Alright guys, thank you very much for your time. Hopefully you guys understand this. Hopefully this video is helpful to you and you can get through this project for me. Thanks very much and hope to hear from you guys soon. Bye.